The last section is on vectors and scalars. The difference between vectors and scalars is that vectors have magnitude and direction, whereas scalars only have magnitude. For example, force is a vector because it has magnitude and direction. Acceleration, the direction of acceleration is important, so therefore it is a vector. Velocity is also a vector. The scalar equivalent of velocity is the speed. Displacement is the distance away from a fixed point and given a certain direction, so displacement also is a vector. If you wanted the scalar equivalent of displacement, it would be the distance. Now we need to be able to determine the sum or the difference of two or more vectors by what's called the graphical method. And we'll give an example here. We have one vector here, the green vector, plus the blue vector, plus the red vector. Now, if we added all these vectors together, where would they point? What would be the sum of these vectors? Now, when we add vectors using the graphical method, what we must do is to place them basically head to toe and see where the final vector reaches, and then from that we can work out what the sum of the vectors is. So let's put them head to toe. We move the blue one up there, so from the top of the green we have the blue vector, and then we place the red vector on the end of the blue vector. So the sum of the vectors is basically the black vector. So the sum of the vectors is the black vector here. So we basically show graphically by placing the vectors head to toe, and the final position shows the sum of the vectors. We have to resolve vectors into perpendicular components along the chosen axes. An example we're going to give is we have a force which is acting in this direction. So the force is 12 newtons acting at 30 degrees to the vertical. No, sorry, is 12 newtons acting at 30 degrees to the horizontal. That's 30 degrees. Now we want to find what are the components in the horizontal and the vertical direction. So we draw a dotted line down here. We want to find out what is the horizontal component of this vector. Now you can see that this is basically a right angle triangle, so we use basic trigonometry to calculate what the horizontal component will be. Now we have the angle 30 degrees, and the horizontal component is the adjacent, so we're going to use cosine. So the horizontal component of the force is the original force F times by cosine of the angle, which is 12 cosine 30. Likewise, if we want to find the vertical component, we want to find out what is the size of this component, which is the vertical component of the 12 Newton force. This is cosine, and here we're looking at the opposite side, which is going to be the sine. So the vertical component of the force is F sine theta, or in this case 12 sine 30. An example that they like to look at is the inclined plane. Here we have an inclined plane with an inclination of 30 degrees to the horizontal. We have an object which is sitting on the plane. Of course it's going to roll down the plane, or slide down the plane. We have to draw the vectors which represent the forces acting on this object. There's a force acting downwards, that is going to be gravity, or the weight, F is equal to mg. There will also be a force which is acting at right angles to the surface. This is called the reaction, or the normal. So what we want to do is find the component of the weight which is acting down the inclined plane. So we take the weight and find out what component of this is actually in the down the slope direction. So here again, we draw the perpendicular to the slope. So we want to find out what this vector is, because this is the component of the weight which is acting down the slope. We know that the angle to the horizontal is 30 degrees, and therefore this also must be 30 degrees. And we're finding the opposite, so it's going to be the sine. So F is equal to mg sine theta. This means there will be an unbalanced force acting down the slope which will make it accelerate downwards. If this object were to be still or motionless or going at a constant velocity, in other words there's no acceleration, there must be a force of gravity acting in the opposite direction. But there is no gravity drawn here, so we can assume that the ball or the mass is going to accelerate down the slope.